Once again, welcome to students and viewers. Today we will discuss the nature of the roots of quadratic equations. A quadratic equation in X is written as ax square plus bx plus c equal to 0, a not equal to 0, a, b, c are real numbers. Now, we already discussed how to find the solution of this equation. X equal to minus b plus minus root over b square minus 4ac divided by twice a, right? So let's quickly review how we derive this solution. So let's start it again. Ax square plus bx plus c equal to 0. So first let us transpose the constant to the right hand side. So transposing c to the right hand side, we got minus c. Now let us multiply both sides by 4a. Multiplying both sides by 4a, right? So we got it 4a square x square plus 4abx equal to minus 4ac, right? Now this can be written as a perfect square, twice of ax whole square, plus this can be written as a product of twice of ax, 2 into twice of ax into multiplied by b, right? Product of 2 to the 4, 4ax into b, 4abx equal to minus 4ac. Now let's recall this identity. A plus b whole square equal to a square plus twice of ab plus b square. So this expression is a perfect square. A square plus twice of ab plus b square. Now if you compare this with this expression, this is a square plus twice of ab, but that third term is not here. So let us try to add the third term here. Twice of ax whole square, a square twice of a into b plus b square. You need third term to make it a perfect square. A square plus twice of ab plus b square. Since you are adding this b square extra to the left hand side, same thing you will do the right hand side also. 4ac plus b square, right? So now left hand side becomes a perfect square. A square plus twice of ab plus b square. You can write it as a plus b whole square equal to b square minus 4ac. Now taking square root on both sides, twice of ax plus b equal to square root of b square minus 4ac. Now we know that square root is either positive or negative, right? So we write it as plus minus b square minus 4ac. For example, suppose x square equal to 9, x equal to plus 3 or minus 3, right? So we write it as plus minus 3. Similarly, square root of this is also plus minus this, right? So we want to find x here. So again we will transpose the term b to the left hand side. Minus b plus minus square root of b square minus 4ac. So what is x? Minus b plus minus square root of b square minus 4ac divided by twice a. This is how we derive the solution of this equation, ax square plus bx plus c equal to 0. So there are two roots of this equation. One is minus b plus square root of b square minus 4ac divided by twice a, and another is minus b minus b square minus 4ac divided by twice a. These are the roots of the quadratic equation. Now let us try to solve a few quadratic equations. Say for example, x square minus twice of x plus 1 equal to 0. Let us solve this equation. Now comparing the given equation with standard form, ax square plus bx plus c equal to 0, we get what we get? A equal to coefficient of x square is 1, B equal to coefficient of x is -2, C equal to constant term here is 1, right? So if you try to solve this equation, then you get x equal to -b plus minus root over b square minus 4ac divided by twice a. So what is b here? -2 plus minus square root of b square minus 2 square minus 4ac. A is 1, c is also 1 divided by twice a, 2 into 1. So you got the answer 2 plus minus square root of -2 square is 4 minus 4 divided by 2. That means 2 plus minus 0 divided by 2. So 2 plus 0 by 2 means 1. 2 plus 2 minus 0 divided by 2 means 1. So roots are identical. Both are 1 and 1. We know that quadratic equation has two roots. So roots of this equation are both are identical, 1 and 1. Here we got b square minus 4ac equal to 0, right? Here 4 minus 4 equal to 0, b square minus 4ac equal to 0 in this equation, right? So we conclude that when b square minus 4ac equal to 0, then roots are identical and same, right? Now let us solve another equation. Say for example, equation number 2, x square minus 7x plus 12 equal to 0. Now comparing with standard form. Ax square plus bx plus c equal to 0, we get here if you compare this equation with standard form of quadratic equation, you get a equal to coefficient of x square is here 1, b equal to -7, c equal to 12. Now x equal to -b plus minus square root of b square minus 4ac divided by twice a. So here -b -7 plus minus root over b square minus 7 square 4ac. A means 1, c means 12 divided by twice a, 2 into 1. So you got 7 plus minus square root of 49 minus 48 divided by 2. 7 plus minus 1 divided by 2. So 7 plus 1 by 2 or 7 minus 1 by 2. That means 8 by 2, 4, or 6 by 2 means 3. Right? So roots are 4 and 3. Now here you see b square minus 4ac here. B square minus 4ac equal to 1 here. 1 is a perfect square, right? So when b square minus 4ac is a perfect square and it is positive, roots are rational numbers. They are not equal, but they are rational numbers, right? Now let us take another example. Question number 3, suppose. Say for example, twice of x square plus 5x plus 1 equal to 0. Suppose comparing the given equation with standard form of equation ax square plus bx plus c equal to 0. Here we get coefficient of x square is 2 here, coefficient of x is 5 here, constant term c is 1 here. Now if we try to solve this equation, you get x equal to -b plus minus root over b square minus 4ac divided by twice a. Now here -b means 5 plus minus root over b square, 5 square minus 4ac, 4 into 2 into 1 divided by twice a, 2 into 2. So you got -5 plus minus root over 25 minus 8 divided by 4. That means minus 5 plus minus 25 minus 8, 17, square root of 17 divided by 4. So you got two roots, minus 5 plus root over 17 divided by 4, or minus 5 minus root over 17 divided by 4. Now you see here, b square minus 4ac, b square minus 4ac is greater than 0, but it is not a perfect square. Root over 17 is not a perfect square, right? That means square root of 17 is not a whole number, right? That is why we find that roots are real numbers, but they are not equal, and more importantly, roots are irrational numbers. When b square minus 4ac is not a perfect square, then roots are irrational numbers, not rational numbers, right? Now let's try another example. Say for example, x square plus x plus 1 equal to 0. Now we're comparing with ax square plus bx plus c equal to 0. We get a equal to 1, b equal to 1, c equal to 1 here. Now roots are x equal to minus b plus minus root over b square minus 4ac divided by twice a minus b 1 plus minus b square means 1 square minus 4ac 1 into 1 divided by twice a 2 into 1 minus 1 plus minus 1 minus 4 divided by 2 minus 1 plus minus root over minus 3 divided by 2. Now square root of minus 3 is not real. There does not exist any real number whose square is minus 3. So square root of minus 3 is not real. Therefore 1 plus square root of minus 3 divided by 2 and 1 minus square root of minus 3 divided by 2 are not real. So what we understood is, when b square minus 4ac, when b square minus 4ac is less than 0, roots are not real, right? Roots are not real. This we will discuss in higher classes. We will discuss complex numbers in that case. So as of now, we will assume that when b square minus 4ac is less than 0, roots are not real. So what we have concluded here is that b square minus 4ac, this actually determines the nature of roots. So b square minus 4ac is called discriminant. This is called discriminant of a quadratic equation, since it determines the nature of roots. When b square minus 4ac equal to 0, roots are identical and or equal. In fact, both roots are equal. That means b square minus 4ac greater than 0 and b square minus 4ac is a perfect square. In that case, roots are rational and unequal. Thirdly, when b square minus 4ac is greater than 0 but b square minus 4ac is not a perfect square, then we find that roots are irrational and unequal. When b square minus 4ac is less than 0, roots are not real, right? So b square minus 4ac determines the nature of the roots of a quadratic equation. That is why this is called discriminant of the quadratic equation. Now let's do some exercise here. Suppose check the nature of the roots of this equation. So let's solve this. Here the given equation is 3x square 4 into square root of 3x plus 4 equal to 0. Here a equal to 3, coefficient of x square. B means coefficient of x is minus 4 root 3. C equal to 4. Now we see b square minus 4ac. We find the discriminant of this equation. B square means minus 4 root 3 whole square. 4ac a into c. You see, this is 48 minus 4 3 are 12, 12 4 are 48 equal to 0. So when b square minus 4ac equal to 0, roots are identical and equal. Roots are identical or equal. Right? Roots are identical or equal. You can check whether it is true or false. Let's check this. Say for example, you try to solve this equation, x equal to minus b plus minus root over b square minus 4ac divided by twice a. Minus b means minus 4 root 3 plus minus root over b square minus 4ac. We already find this, b square minus 4ac is 0 divided by twice a, 2 into 3. So we got 4 root 3 divided by 6 plus minus 0. Now roots are 4 root 3 plus 0 by 6 or 4 root 3 minus 0 by 6. This gives root 3 by 3 or this gives root 3, 2 root 3 by 3. Here you get 2 root 3 by 3. 4 root 3 minus 0 means 4 root 3, right? Now if you convert into simplest form, you get this 2 root 3 by 3 or 2 root 3 by 3. So roots are identical and in fact they are equal. Let's do one more exercise here. Find k so that this equation has two equal roots. Solution. Now given equation is kx into x minus 2 plus 6 equal to 0. So if you simplify this, you get kx square twice of kx plus 6 equal to 0. Here a equal to k, b equal to minus twice k, c equal to 6. Now say this equation has two equal roots. The given equation has two equal roots. That is b square minus 4ac equal to 0. Right? And b square means minus twice of k square. 4 into a means here k. C means 6 equal to 0. Now 4k square minus 4k into 6 equal to 0. Let's take k common. 4k into k minus 6 equal to 0. Either 4k equal to 0 or k minus 6 equal to 0. K equal to 0 or k equal to 6. So you find two solutions for k. Now if k equal to 0, this will not be quadratic equation, right? If you for k equal to 0, the equation will not be quadratic. Therefore k equal to 6. This is the answer. We got two solutions for k equal to 0, k equal to 6. Product of two polynomials equal to 0. So either this polynomial is 0 or this is 0. Now if k equal to 0, you see that this will not be a quadratic equation at all, right? So k equal to 6 is the solution. Now let's check if we did correct thing or not. Let's put k equal to 6 here. If you put k equal to 6 here, then you get 6x into x minus 2 plus 6 equal to 0. 6x square minus 12x plus 6 equal to 0. X square minus twice x plus 1 equal to 0. Right? Now x minus 1 whole square equal to 0. That means x minus 1 square root of x minus 1 is square root of plus minus 0, or that means plus minus 0. X equal to 1 plus minus 0, that means 1 and 1. Roots are identical and equal. So when you find k equal to 6 here, roots are equal or identical. Now let us solve the third equation, third problem here. Is it possible to design a rectangular park of perimeter 80 meter? So rectangular park, it's suppose length is x. Now perimeter is 80. Total boundary is 80 meter. Area is 400 meter square. So find the length and breadth. So we assume that, let us assume length equal to x meter. So what is breadth? You see, perimeter. Perimeter means 2 into L plus B equal to 80. So length plus breadth equal to 40. Right? So breadth will be 40 minus x. If length is x meter, breadth equal to 40 minus x meter. Area equal to length into breadth, L into B. That means x into 40 minus x. Now x into 40 minus x equal to 400. Here it is given area. So this you simplify, 40x minus x square minus 400 equal to 0. Or you can say x square minus 40x plus 400 equal to 0. Multiplying both sides by minus 1. Now let us solve this. X equal to minus b plus minus root over b square minus 4ac divided by twice a. You see, minus b means 40 here, plus minus root over b square minus 40 square, 4ac. 4 into a means 1, c means 400 divided by twice of a, 2 into 1. 40 plus minus, you see, minus 40 square means 1600, means 4 into 400, 1600. So this is 0 divided by 2. So it is 40 plus minus 0 by 2. That means 40 by 2. Answer is 20. So x equal to, you find x equal to 20. X equal to 20, that is length equal to 20 meter. So what is breadth? Equal to 40 minus x. That means 40 minus x is 20 meter. So length and breadth are here same. Although it's a rectangular park, but it is actually a square park, not a rectangular park, right? Now we can say that every square is a rectangle, but every rectangle may not be a square, right? Every square is a rectangle, but every rectangle may not be a square. Here in this case, it was said that it's a rectangular park, but it is not a rectangular park, it's a square park. Length and breadth are same, right? 20, 20. Perimeter is 2 into L plus B. 2 into 40, 80. Area equal to 20 into 20, 400 meter square. So what is your answer? It is not possible to design rectangular park. Rectangular park here. It is not possible to design a rectangular park. It's a square park, right? Thank you for watching. We will discuss some more examples in next class. Bye bye.